Hi everyone, welcome to this new section, and in this section we are going to specifically talk about decentralized orders in Hyperledger Fabric. Now in most of the cases I have seen that people use centralized orders where they have a central ordering organization, and that organization holds just the order, and in that case it makes it truly centralized ordering system, and only that specific organization takes part in the consensus, and the rest of the other organization, they are the peer organization, like they just hold the peer nodes. Now in this section we are going to talk about, or implement how we can set up a decentralized ordering nodes where these ordering organizations or these ordering nodes will be held by multiple organizations. And what I meant by is, so by the end of the section, we should be able to run a fabric network where there will be multiple organizations, and every organization will have their own ordering nodes along with the peer nodes. That will make it truly decentralized, because blockchain is meant to be decentralized. And if we have a single organization which just holds the orders, then it makes it truly centralized. And that also make it as a single point of failure as well, because if that organization is unhealthy, then the entire blockchain network will not work. So let's go ahead and see this in the screen as well. So if you see, this is a typical fabric network that most of the implementations use. They have multiple organization like org1 and org2 and ordering org. Now if you see org1 is having their its own dedicated certificate authority, along with it has two peer nodes. Then similarly, we have org2 as well, and org2 is also having one certificate authority and two peer organization or two peer nodes, right? Then we have a third org, which is an ordering org, and this ordering org is containing or holding only orders, and there is a certificate authority. So now in this particular diagram that you see, we have three organizations, like two of them are a peer organization and one of them is an ordering organization. Now if you see from this this picture carefully, that the only this particular org, which is order org, this order org is having all the orders. So all the 5 orders are maintained by this org. Now remember, now think of a scenario where this ordering org is not responding. In that case, the network will not be functional, right? And all of them are connected to the same channel, like all these nodes are the part of same channel, and this is how the typical system looks like, right? Now the goal of this section is, I'll show you the another representation. Now the goal of this section is that we are going to have multiple organization, and each of the organization will have both peer nodes and the ordering node. So if you see this diagram, we have org1, and org1 is having its own dedicated authority, then it has its two peer nodes, and then it also has ordering nodes, right? Same goes for org2 as well. In org2 they have its own dedicated certificate authority, which is good. Then we have peer organizations as well, the peer nodes, and then we have ordering nodes as well, right? So in this case you see that now there is no single organization which is controlling the consensus. Rather, the consensus is now driven by both the organization, right? Now there is no single point of failure. Let's go to the other screen as well, the code repository. So I have added this new section called decentralized order, and this particular section has like multiple markdown files from where you can just learn about the implementation steps as well, and that we'll see in the upcoming lectures as well. So this is the whole concept, right, that I was talking about, that we are going to have multiple ordering nodes, and then the channel membership will be shared by these different organizations, right? And the consensus will be distributed across multiple organizations. So this is how the topology in our case is going to look like. So we are going to have two organizations. One is org1 and another one is org2. There will be one channel called test channel. And then we are going to have orders, 3 orders in the org1. So org1 is going to have 3 orders, which is node 1, node 2, node 3. Then org2 is going to have 2 orders, node 4 and node 5. And then both the organizations are going to have 2 peers, peer 1 and peer 2 respectively. Now the flow from the user's perspective is going to be same, like they are going to send the transaction will be sent to the orders, and then the transaction will broadcast it to the peers as well. Same I have mentioned here as well in the below. So we are going to have 2 organizations, org1 and org2. org1 is managing or node 1, node 2, node 3, and org2 is managing node 4 or node 5. We are going to have one channel, and all these 5 ordering nodes, they will be the part of same channel called test channel. Consensus in this case is going to be draft consensus because we are using Fabric 2.5 as of now. So all the nodes will be running raft consensus. Then the client will be sending up the transaction, how it used to happen earlier as well. And then both the organization, which is org1 and org2, they are going to have two peers each. Right. So this was it for this lecture. Just to conclude the lecture, we are going to move away from this particular representation because in the previous lectures we were having this kind of a topology where each of the organization was either a peer organization or an ordering organization. But now in this particular section, we are going to focus on this aspect where the ordering nodes will be divided across multiple organizations. So this was it for this lecture, and I'll see you in the next one.